and we want to find all the zeros of the polynomial function. So we have this polynomial function, and the degree is 5. And so we should expect 5 zeros. And sometimes we want to find the exact zeros. And sometimes, we can use the rational root theorem and we can figure all that out, or we can use a graph to help illustrate exactly where the zeros are. So we have our graph over here, and we have a double root at -2 because the graph comes up and is tangent to the x-axis but doesn't cross it. So we know we have 2 roots at -2, and then we see that we have another root at x equals 1. So we're going to have 3 real roots, and then that's going to leave us with 2 imaginary roots that we'll have to calculate after we take those first 3 factors out. And so right from the beginning, I know that I need to, I can check my degree first. So 5, 4, 3, 2, and we're missing 1. So I'm going to rewrite this: x to the 5th plus 3x to the 4th plus 9x cubed plus 23x squared plus 0x minus 36. I had to add that 0 coefficient in there in order to do our synthetic substitution correctly. Now I know that -2, -2, and 1 are going to be factors of this polynomial, and I know that the remainder will be 0. So I'm going to check those. So the first one we're going to do is -2. So we'll take our coefficients from above, and we have our lead coefficient of 1, 3, 9, 23, 0, and -36. So those are the coefficients that we're going to use. And the reason that we have to do this is because we have to take these known factors out, these real factors out, so then we can use our quadratic formula to figure out exactly what our other 2 imaginary solutions will be. So we're going to add down and multiply in the diagonal. So we get 1, multiply, we get -2, add down, we get 1, multiply, we get -2, add down, we get 7, multiply, we get -14, add down, we get 9, multiply on the diagonal, we get -18, add down, we get -18, multiply on the diagonal, we get +36, add down, we get a remainder of 0. So we knew that was going to happen, and we actually know that it's going to happen one more time because we have a multiplicity of -2, so we're going to substitute in -2 again. And we are going to use our remaining polynomial, which we have down here, which is 1, 1, 7, 9, and -18. And so we're going to add down and multiply in the diagonal. So we get 1, -2, add down, we get -1, multiply in the diagonal, we get +2, add down, we get 9, multiply on the diagonal, we get -18, add down, we get -9, multiply on the diagonal, we get +18, and add down, and we get a remainder of 0. And then we can check this, we know one more of our real solutions. We know x is equal to 0 is a real solution. X is equal to 1 is a real 0 or real solution for this polynomial. So I'm going to use synthetic substitution with the value of 1. And I'm going to use the remaining polynomial coefficients from up here. So we got 1, -1, 9, and -9. And we're going to add down and multiply in the diagonal. So we get 1, then we get 1, then we get 0. Multiply in the diagonal, we get 0. Add down, we get 9. Multiply on the diagonal, we get 9. Add down, and we get 0. And so what this tells us is that we factored out three factors. So we factored out x plus 2. That's actually a double root. And so we can have that, we can square that up there because that is a double root. Both of these represent the factor of x plus 2 squared. And then we have one more factor that we know, and that is going to be x minus 1. So we got our factor right here from these two synthetic substitutions, and then we got our last factor from this. Now, x minus 1, that is our factor for our 0 here, and x plus 2 squared, that is our factor for x minus 2 there. So what do we have left? We know that this is our remainder, this is our constant, our linear, and our quadratic. So that's what we have left, and we can write that down next to this to finish out our polynomial. So 1x squared plus 0x plus 9, and that is our last part of our polynomial. So we have 1, 2, 3 zeros, and then this will be 4 and 5. So we have to figure out what our zeros are here. So we'll take this polynomial and set it equal to 0. So we get x squared plus 9 equals 0. Subtract 9 from both sides. We get x squared is equal to negative 9. Then we can take the square root, and we get, whenever our square root cancels our square, so we get x. And anytime we take the square root when we're solving, we have to include plus or minus. And then we also have, we can rewrite our radical. We can rewrite that as the square root of 9 times the square root of negative 1. And we know the square root of negative 1 is I. So the square root of 9 is 3, and the square root of negative 1 is I. So that accounts for our last two zeros. So the solution for this polynomial is we have x is equal to negative 3i, 3i, negative 2, and 1. So that's 1, 2, 3, and then we have a double root or multiplicity of 2 at negative 2, so that is 4 and 5. And if we go back to our function, we see that we have our double root at negative 2, and we have our just one solution at 1, and so our work matches our graph.